All right, in Unit 2, Lesson 8, we're going to graph complex numbers and also find the angle, which is called the argument that the angle makes with the x-axis. So, complex numbers, they can be graphed on the typical coordinate axis, except we're going to modify it. Instead of an x-y axis, the typical x-axis is going to be for the reals, and the y-axis refers to the imaginary, okay? So typically you're used to x and y, but on the imaginary plane, we're going to let this be the real value and then the imaginary part, okay? And it still moves the same way, plus, minus, up, down, left, right. So if we had the point a plus bi, we would go to the right a and we would go up b units, okay? So it will look like an xy axis, but we know that this is a complex coordinate axis. So on my first example, I just want us to plot 4 points. So I want to think of this as 7, 1, 2, 3, 4, 5, 6, 7 in the real direction, and then positive 3 in the imaginary. Label your points with the letters so I can clearly identify them. -2, -4i, so -2 in the real direction, which is left, and then down 4. All right, C, you can think of this as plus 0i, since there's not an imaginary part. So we're going to go to the right 3, and then we don't go anything up and down. And then the same thing, we can make that 0 in the real direction, and then I'll go up 5 units. Okay. So another question might say, which of the following points is the farthest from the origin? So remember that the origin is 0, 0. So what I know is that C is 3 points. D is 5 points because those are in straight directions. There's a couple of different ways to find A and B, okay? So we talked about finding the length yesterday, which is the absolute value, all right? And it's also kind of the Pythagorean theorem if you make a little right triangle. So it definitely looks like A is farther, but mathematically we can find that distance. So we went, remember, if we do the absolute value, we would have the real part squared, the imaginary part squared, and so 49 plus 9 is root 58. And root 58 you can do a decimal, but 5 squared is 25, and that's root 58. So we can definitely see it's going to be A. All right, so remember that's the real part plus the imaginary part. Okay, just a little application of maybe why we found the distance yesterday or the modulus. Okay, the next thing that we're going to find is the argument. So the argument is kind of a fancy way to say the angle that is formed from the positive side of the real axis. So you can kind of think of this as your starting point, okay? So we don't start at 0, 0. So the angle is going to be this measurement. And since they are the coordinate axis, whenever you go, I'll draw it down here, up and down. So from here to here, I can act like that's 0 degrees. That would make 90 degrees. And 180. When you rotate counterclockwise, it's a positive. And if you rotate in the negative direction, it's going to be a negative angle. Okay? For our sake, we're going to stick to quadrants 1 and 4. So most of your angles should be less than 90. There's a little bit more complex math that happens when you're in quadrants 2 and 3. So we're going to stick to those. The way you find it is if you have a scientific calculator, you might see this button on your calculator. That is really inverse tangent. And so what you do is you take your imaginary value and you divide it by your real value, okay? And you should get an angle between 0 and 90, whether it's positive or negative, okay? And you can always graph your point to double check your answer. I'm going to show you how to use your computer to find this. So on a computer, it's easier. We'll open up a window and we're going to use arctangent. Arctangent and tangent with the -1, these mean the same thing. It's just easier to type in arctangent. The thing you want to be careful of is you need to use parentheses. So you want to take your imaginary number divided by your real number, and then you want to close your parenthesis. Okay, so if you don't use the parenthesis, then you will get a different answer because the computer is doing something different with order of operations. Okay, so let's do example 3. Okay, so if I want to find the angle, I know I've got arctangent of my imaginary part is 7 divided by my real part is 5. Okay, so I'm going to show you. We're going to come right up here, and I'll make it a little bit smaller. Sorry, I'm playing around with this. Okay, so I'm going to open up a new window, and I'm just going to type in arctan parenthesis, and we wanted 7 divided by 5 parenthesis, and we want to do in degrees. There are arctangent calculators if you find that website as well, but I'm just going to type in the URL bar. Okay, and so you notice it says right here, you can see the parentheses around the 7 and the 5, and it's 54.5 degrees. Okay, so that's what we're going to use. If we sketch this, just to kind of double check ourselves, we went 5 in the positive direction and 7 in the positive direction. So the angle right there, this is what we found. This is 54.5 degrees. Okay. All right, let's go ahead and scoot over. Oops. And we want to find the argument for this angle. So I'm going to graph this one first. So we go 1 in the real direction and -2. All right, so I'm kind of looking for this angle right there. Okay, so we've got arctangent, the imaginary divided by the real. Okay, so arctangent of -2 divided by 1. I'll just go back here, and I'm just going to type it in right here. -2 divided by 1. So notice I do have that in parentheses. And so we get -64, and we knew that our angle went down, so that should make sense. So -64.4. You can do the whole number or the decimal. A quiz should be multiple choice. So -63.4. Okay. Now, an advanced, we'll actually be learning this a little bit later on the year, but just in case you're ready for this now, this would be advanced, okay? So what happens if we're not in the first or second quadrant? Well, it's a little trickier, okay? So first I'm going to sketch this. So I get -6 and then up 3. And so I'm actually looking for this angle right here, okay? So it should be positive. And so I want to find arctangent of my real, imaginary divided by my real. So 3 divided by -6. 3 divided by -6. We want in degrees. And so this tells you that it's -26. And so that might not make any sense to you. So what that's really doing is it's called a reference angle. And that's telling you the part actually is not in your angle. So I'm going to remember 26.6. And so that 26.6 is actually referring to this. Okay? It's not a negative angle. There's other math going on to why the calculator would tell you it's negative, okay? So it's not wrong. It's just used for something else. So what we really need to do, and that's why it's advanced in the second and the third quadrant, is this entire thing. It's a straight line. And if you're like a skateboarder or you're a diver or a flipper, this is a 180. It's flat, okay? So we actually need to take 180 and we need to take off that part that we don't know. See why this is kind of advanced? I know. So then 180 minus 26.6 is 100. I'll just go ahead and borrow. So 7, borrow 9, So I get 4.351. So this is actually 153.4 degrees. Now, if this is too much for you, don't worry. I just wanted to kind of preview why we're not doing the second and third quadrant. Um, Probably in quarter 4, we will learn more about this, okay? So if you're fine with example 3 and 4, then you're good to go. Okay,